Good morning, everybody. Welcome to the snowy, but overcast, but wonderful Monday morning of Chem 1105 with your host, me, Dr. White. All right, you all should have received an email with your individual scores for test number one. Everybody did pretty good. I think the average was 93 out of 100. That's good. Test one usually has the highest average of all the tests I give. All right, here's what I like to do. I like to discuss something real quick. Then we'll go through test number one answers. I will cut it out of the video. How do you like those special effects? But by, say, tomorrow afternoon or evening, I will have a private YouTube video posted, and I'll send you the URL so you can access it to see the answers for test number one. Now, the other thing I like to talk about is the labs. Hand-in labs. They're easy points. But if you don't hand them in, you're going to lose 10 points, 10 per lab. And therefore, hand in your labs. Don't forget to take a picture of your lab, selfie with you and some equipment of the lab. But get them in. If you need help with any lab, guess what? Come to my office hours. If you're working during my office hours, let me know, and I'll help you out with another Zoom time. We can meet together. So make sure you hand in your labs because it helps you get a good grade. All right. Let's start and go through test number one answers. And for whatever reason, this person Key gets a good score. Actually, that's me. Up here in the corner, that's my monogram. Took me my first semester, non-Western civilization history course in high school to develop that. I was bored. I got one of the highest scores in the class, A's, but I was still bored. All right, let's go through this. One thing I should point out, if I make a grading mistake, you should never be penalized for a mistake I make. Never. Therefore, email me with what you think the mistake is, and I'll check, and if it's wrong, I'll correct it, because you should never be penalized for a mistake I make. Now, while I'm going through the test now, don't ask questions. Why did you take off points for this? See me in private after class or my office hours, and I'll always be happy to explain any score on a test problem. And the same thing goes for a lab. Now at labs, I just don't have the time to say this is wrong and why on the lab, but come to my office hours and I'll be more than happy to do that. And that's test number one. Again, I am thirsty this morning. If I made a mistake, email me and let me know. When you look at the answers and go back and look at your test, and the email sent you individually with how many points for each answer, check that I didn't make a mistake where something was 4 points and I only gave you 3. It rarely happens, but the last time I checked, I don't walk on water unless it's frozen. Even then I stay off, which means I can make mistakes. It's rare, but I do, and you should never be penalized. Now, any questions about test one? And I would have a question, and that question is, what grade am I now getting in this class? Well, it's pretty early, but let's go to, in fact, let's go, let me open up something else. All right, if you look on your screen from the syllabus, page 11, the grade cutoffs, which indicate also what grade you're currently getting. You forget about the labs at this point. If you got 90 and higher, you got an A, 80, 89, B, C, 70, 79, D, 60, 69, F, 59 or less. And this is on page 11 of the syllabus, which you can, download from Blackboard. Excuse me again, too much water. Now, the lowest test is still always dropped. And therefore, if you didn't get a grade you wanted on test one, everybody can still get an A. But as I said, and it made me so happy, it really did, the average was 93. The majority of the class got either A's or B's, which is what I expect when I teach. Now, test number one is always the highest average of the semester. You should keep up studying and doing the practice problems. Tomorrow, on tomorrow's Zoom meeting, I will do chapter 4. Well, I got to get that fixed. Chapter 4. Ooh, this is broken too. Chapter 4 test. Chapter 4 practice problems. You'll understand why they're practice problems. Test number 2 historically is the lowest average of the semester tests. But it doesn't have to be. I've had some sections in the past where test 2 was very high too, but you got to keep up and study. All right, any questions? Well, I was thinking about it on a personal note, and I'll explain a little more later in the semester. We get into organic chemistry. This weekend, my kitchen sink stopped up. I think it's been about 10 years since I had that problem. And being an organic chemist, I learned something when I first bought this home. I can find it. Huh. I had that bookmark. All right, everybody see on your screen, instant power, hair and grease. And I'll explain later in the semester that this is the best drain cleaner you can buy. It's the only one that's made up of sodium and potassium hydroxide. I'll teach you later on. Those are bases. All the rest of the drain cleaners are acids. This is what the plumbers use, not the other stuff. This works. I've been using this, well, not that often, but the first time I used this when I bought my house wow, almost 25 years ago. I've been here that long. Boy. But anyways, this stuff works. And on the bag, it's in a Ziploc bag, the bottle, and says use proper goggles and gloves when you use it. And I do follow the instructions. The only thing I do different when it's a clog, like in my kitchen sink, they say 15 minutes. I give it about a half hour, 45 minutes. And then you pour hot water. My sink, kitchen sink, takes about 2 or 3 minutes for the water to get hot. So what I do is I go down to my utility room, fill a bucket with hot water, bring it up, dump it, do it a second time. Boom, it was unclogged. And my brother-in-law has done it in his house in the bathroom for her hair. And like I said, I've had many students over the years use this for kitchen clogs, grease, and bathroom drain, the tub, or the sink hair. And that's a good note from Dr. White. All right, let's get back to chapter. If I can find it. Let me close some things. I thought I had it open. Obviously, I didn't. There we go. Zoom was playing hard to get. It does that once in a while. All right, we're talking about balancing a chemical equation. Remember, a chemical equation is a way of showing a chemical reaction. At the base of the arrow are the reactants. You should know this. Sometimes, since I've spent most of my life in the chemical industry, we also, and I probably will at times, call them starting materials. At the head of the arrow are the product or products. In this case, C would be a product, A and B would be a reactants. Now, chemical equations have to be balanced. What does that mean? Because of conservation of matter in a chemical reaction, you never destroy or create matter. Nope, you don't. Therefore, on the reactant side, you have to have the same number of the same type of atoms as on the product side. Now, if you look here, we have 2 oxygen, but in water, there's only 1. Well, if this is 2 oxygen, this side has to get 2 oxygen. You can't change the formula, nope, but you can change how many of that molecule or atom is on each side. And the number in front of an element or molecule formula is called the coefficient, which I probably spelled wrong. And to get 2 oxygen, I'll put a 2 there. 2 times 1, 2 oxygen. But here, 2 times 2 is 4 hydrogen. This side has to have 4 hydrogen. Oh, no, it doesn't. Only 2. How can you get that to 4? Change the coefficient. Put a 2, 2 times 2, 4 hydrogen. And that's how you balance it. Let's check. 4 hydrogen, 4 hydrogen. 2 oxygen, 2 oxygen. It's balanced. And we'll learn later on this chapter or next chapter that the coefficients are very important in a balanced chemical equation. But for now, that tells me 2 oxygen plus, 2 hydrogen plus 1 oxygen makes 2 molecules of water. You know something? I'm going to let you try one. And here's the one to try. Sodium, Na, plus chlorine gas, Cl2, makes NaCl, sodium chloride, table salt. And this is not balanced. Your turn. Balance that chemical equation. Go. Go. Yeah, right. And I have something set up. And that is, are you done? When you're done, click on your screen, yes. Don't use choice 2. This when you're done, click on your screen, yes. And remember, I try and give everybody time to finish. So if you finish early, please be patient. All right, let's do this. I have 1 sodium. I have 1 sodium. Oh, that looks good. But wait, I have 2 chlorine, but only 1 chlorine on this side. How do I get it by 2? I can't change it, put a 2 there. Nope, that's something different. But I can change the coefficient, the number in front. 2 times 1 is 2 chlorine. But how many sodium? 2 times 1, 2 sodium. Oh, I only have 1 sodium. I got to get it to 2. So I changed the coefficient. N2 is nothing that exists. But now I have my 2 sodium. Now, here, let's check. Is it balanced? 2 sodium, 2 sodium, 2 chlorine, 2 chlorine. Success. We did it. All right. Now, when it comes to balancing a chemical equation, there's some, I call them tricks, but really skills to use. Let's look at the following. And here I have C3H8. That's the chemical formula for propane. That's the stuff you get in those white tanks for your barbecue. And when it reacts with oxygen, O2, this is called combustion. When you burn something and you get carbon dioxide, CO2, water, and the important thing which you don't write down here at this point, heat. And that's how you cook things on a barbecue. Now the question is that balanced? And the answer is no. Here's 3 carbons, here's 1. Now listen carefully. You don't have to follow what I'm going to recommend as a trick, but over the years, and I've balanced chemical equations a lot, this makes your life easier. I'll say it again. I've done a lot of balanced chemical equations. I found, and my students found it helped them, this makes your life easier. When you're balancing a chemical equation, leave hydrogen and oxygen for last. When you're balancing a chemical equation, leave hydrogen and oxygen last. All right, so that leaves me carbon. I have 3 carbons here. I only have 1. How do I get 3? Change the coefficient. 3 times 1, 3 carbons. Well, that's done. And all I have left is hydrogen and oxygen. So I'll do the hydrogen. I have 8 hydrogen. Here, oh, I only have 2, but I need 8 for this to be balanced. Well, how do I get that to 8? Change the coefficient. 4 times 2, 8 hydrogen. Now, on this side, I have 2 oxygen. Now, watch closely, but first, I'm thirsty, so I'm going to get some water. Now, on the product side, how many oxygens are there? You count all the oxygens in all molecules on the product side, head of the arrow. So we have 3 times 2, 6 oxygen. Here we have 4 times 1, 4 oxygen. I add those together, and on the product side, I have 10 oxygen. On this side, I only have 2. How do I get that to 10? Multiply it by 5. And 5 times 2, 10 oxygen. Now, is it balanced? Let's find out. 3 carbon, 3 carbon. 8 hydrogen, 8 hydrogen. 10 oxygen, 10 oxygen. We did it. Yay. Remember, you count all the atoms. And on the product side here, I had to count the 6, 3 times 2, oxygen. And the water, 4 times 1, 4 oxygen to get 10. Your turn. Let me rewrite that 5. Balance the following equation. Remember, leave a hydrogen and oxygen last. Your turn. And remember, when you're done, click on yes. If you're not done, wait. And I try and give everybody time to finish. Remember, you can only change the coefficients. All right, my turn. All right, this is balance. We got 5 carbons here, 1 there. Nope. Well, this is 5 carbons. How do I get 5 carbons here? Change the coefficient. 5 times 1 is 5 carbons. And since I'm going this way, all that's left, remember my advice, always leave hydrogen and oxygen last. I have, 12 hydrogens. Over here, I have 2. I need 12. How do I get it to 12? 6 times 2, I now have 12 hydrogens. This side, I have, 2 oxygen. How many oxygen on the product side? First molecule, 5 times 2, 10 oxygen. Water, 6 times 1, 6 oxygen. That means I have 16 oxygen. Oh no, I only have 2 here. How do I get that to 16? Put an 8 there. 8 times 2, and hold on one sec. Now you can see it better. 8 times 2 is 16 oxygen. Now, is this balanced? Well, we check. 5 carbon, 5 carbon. Ooh, looking good. 12 hydrogen. 12 hydrogen, looking better. 16 oxygen and 16 oxygen. It's balanced. Yay. And that's how you balance it. I look at the clock. It's time for a 5-minute break. I'll see you in 5 minutes. I can get up and stretch. Looking good. Let's get going. All right. Now, balancing chemical equations can be challenging, and let's try a challenging one. And here, this is not balanced. I'm going to let you try it first, and then I'll do it. Remember my advice. Leave hydrogen and oxygen last. One other thing I should point out, in this molecule, one sulfur, but it's inside a bracket where there's a 3. So that tells me there's 3 sulfur here and 12 oxygen. Now, is that all? I don't know. You're going to have to find out. But remember, inside a bracket, it's the atom multiplied by the number. And your turn. Have some fun. Remember, leave hydrogen, oxygen last. That's my advice to you. It's a trick that's worked for me for a long, long, long time. And remember, I give everybody time to finish. Oh, excuse me. Again, be patient. I give everybody time to finish. Finish. All right, my turn. Now, if we look at this, well, aluminum Al is non-zero. There's one here. Ooh, there's two aluminum here. How do I get two on both sides? Change the coefficient. Now there's two aluminum on both sides. Then hydrogen, oh, Dr. White says, leave that to last. So I will. Sulfur, there's one here, but 1 times 3, there's 3 sulfur. Well, I need 3 sulfur on the reactant side. So how do I get that? With a coefficient 3. 3 times 2. What did I say? 3. Oops. Yeah, I'm looking at the wrong thing. I just confused myself. Bad, Dr. White. 3 times 1, 3 sulfur. Well, if you look on the reactant side, I've done aluminum, I've done S sulfur. All I have left is hydrogen oxygen, and I saved them for last. On the reactant side, 3 times 2, 6 hydrogen. On the product side, 2 hydrogen, but I need 6. So how do I do that? You can't change that number, no, but you can change the coefficient. 6 times 2, 12 hydrogen. What did I say? Oh, I messed myself up. I was thinking of another problem we just did. I was looking up here. No, we want 6 hydrogen. Put a 3 there. 3 times 2, 6 hydrogen. Notice by writing this down, I caught my mistake. And finally, we have oxygen. 3 times 4, 12 oxygen. Here, 4 times 3, 12 oxygen. I think we're almost done. Let's check. 2 aluminum, 2 aluminum, 3 sulfur, 3 sulfur, looking good. 6 hydrogen, 6 hydrogen, 12 oxygen, 12 oxygen. It's balanced, yay. And that's how you balance it. Remember, when you have brackets and a subscript, that's this number times the number inside. That's how we got 3 sulfur. That's how we got 12 oxygen. Now, there's one more type of balanced chemical equation, and that's called even odd. And what is that? This reaction. And this reaction, you take iron, react it with oxygen gas, you get ferric oxide, also known as rust. That's how cars rust out. If the paint, the coating, which is on there, your paint job, protects the metal from the oxygen. But if that coating wears away or gets chipped away, that's where a car rusts. All right, now, if you notice, here I have 2 oxygen, here I have 3, even odd. There's no way, by the way, coefficients are always whole numbers. And later on, you'll learn coefficients are exact numbers. There's no whole number I can multiply 2 times to get 3. There's no whole number I can get multiply 3 times to get 2. Oh no, what do? You use the even odd trick. What's the number they both go into? Well, you multiply 2 times 3, and that's 6. So if I had 6 oxygen, I'd put a 3 there. If I have 6 oxygen on this side, I need to put a 2. And that's why I say multiply the 2 times each other. They both go into that number an equal time. Again, to get the same number of atoms on each side for oxygen, I can't multiply 2 times the whole number to get 3. I can't multiply 3 times the whole number to get 2. So I use the even odd trick. Multiply the atoms on each side of that element, and that's the number you need. 2 times 3 is 6. 6 oxygen. Coefficient would be 3 there. Coefficient here, 2. Am I done? No. 2 times 2, 4 iron. How do I get 4 iron on this side? Put a 4 there. 4 times 1, 4 iron. Are we balanced? I don't know. Let's check. 4 iron, 4 iron. 6 oxygen, 6 oxygen. We're done. And that's the even odd trick. And let me have one for you to try. By the way, KCO3, potassium perchlorate, is rock solid rocket fuel that decomposes with the spark, the potassium chloride plus oxygen plus a lot of heat. You need to balance it. Your turn. Use the even odd trick. Hint. Remember, I give excuse me, everybody time to finish, so please be patient. I should have a sign I should hold up. All right, my turn. Now, if we look at this balanced chemical equation, is it? No. 3 oxygen, 2 oxygen. Uh-oh, this is even odd. How do you do that? Well, what's the number they both go into? And this is another case where it's 6 oxygen. How do I get to 6 oxygen? Well, oops, wrong number. I got the wrong side. 2 times 3 is 6. How do I get this to 6? 3 times 2. So, but this side now has 2 potassium and 2 times 1, 2 chlorine. How do I get the same on this side? change the coefficient and put a 2 there. 2 times 1, 2 potassium, 2 times 1, 2 chlorine. And let's see if we're done. 6 oxygen, 6 oxygen, 2 potassium, 2 potassium, and 2 chlorine, 2 chlorine. Again, success. We're done. Now, you'll see I have separate practice problem of my own for this chapter, chapter 5, first part, where you balance chemical equations. Also, you'll see there's a lab we'll be doing this semester, probably next week, I think, I don't know, where you have to balance chemical equations and hand it in for your 10 points. That one, you don't have to take a selfie. I mean, hold up the lab and you don't. All right. And I think last Wednesday, but I'll do it again today, I have never broken a promise to myself and other people either, but I know for 100%, I've never broken a promise to myself. On test 2, there'll be 3, maybe 4 balanced chemical equations. Each one, 3 points. So that means on test 2, coming up in the future, week or 2 or 3, whatever, there will be at least 3, maybe 4 balanced chemical equations. On my final, same thing. There'll be at least 3, maybe 4 balanced chemical equations. It's a skill you need to have. Hint, it's a skill you need to have. All right, let's move on, unless there are any questions. And I remember I talked about the coefficient. I think I spelled it right even on my slide here, I mean on my whiteboard. And remember, in balancing equations, chemical equations, the coefficient is always a whole number, never a fraction, never a number with a decimal point. And I showed you how to balance it. And we did our practice time. Oh no, yay, it's time to start a new area, and that's the mole. Now, the mole concept is probably one of, if not the most, probably one of the most important concepts in all of general chemistry. Now, in chemistry, the mole is not a fuzzy little animal that digs holes in the ground. Nope, nope, no. The mole is the counting unit used by chemists. And it's time for me to be subtle. And know this, you should know that the mole is the counting unit used by chemists. If you go into the supermarket and buy eggs, you can't go in there and say, oh, I'm going to buy 3 eggs. No, they're sold by the dozen, 12. Please don't try and go in and buy 2 or 3 eggs. Nope, they'll think you're, ooh, all right. I like that. Ooh, crazy. All right, but in chemistry, the mole is the counting units of chemists. You should know that. And one important way of defining a mole is a unit that contains 6.02 times 10 to the 23rd units. This is called Avogadro's number. And you should know that 6.02 times 10 to the 23rd is Avogadro's number. Avogadro was I guess was, a very famous, I don't know if they even called it chemist back then, Italian chemist, I'll call him a chemist, scientist. And his work helped establish the understanding of the mole. Now, he didn't come up with 6.02 times 10 to the 23rd. Unfortunately, I can't remember their names. Two German chemists did that. But because that number, 6.02 times 10 to the 23rd, is so critical for the mole, it was named in honor of Avogadro. Well, before I was born, I would have named it by the German chemist who came up with that, and then something else for Avogadro. Speaking about which, and here's, I guess, a picture of him. And he was living his work between about 1880s, early when he did his work. And Avogadro's law, which I'll talk about when we get into gases. But the mole, I like to use the old name, MOLE. Recently, in the last 20 years, they changed to MOL. I don't like that, so I'll put the E there. And if you notice here, they have 6.02214.076 times 10 to the 23rd. Notice that's 1, 2, 3, 4, 5, 6, 7, 8, 9 significant figures. Now, for my class, I use this, 6.02. This is a calculated number or a measured number. Therefore, that I use, and you should use, 3 significant figures. One time when I had a little time to kill long ago, I looked and found there was a credible website that had, Avogadro number times 2, I think it was 18 significant figures. Who would need that? Don't know, but somebody did because they took the time to calculate it and measure it to that accuracy. But let's get back. The mole, that's the chemist counting unit used by chemists. And one definition of a mole is 6.02 times 10 to the 23rd units. Just like you buy a dozen eggs, that's 12 plus 10 plus 2. A dozen is 12. A mole is Avogadro's number, 6.02 times 10 to the 23rd. Now it's time to talk about something personal, Dr. White. My birthday is the end of December. And my all-time favorite birthday gift I wish somebody would give me, and there's time for you to save up, I would like a mole of pennies. Yes, only a mole of pennies. How much is that? Well, one time I calculated it's roughly 100 million piles, and each pile has $1 billion in pennies. 100 million times $1 billion, that's probably more money that is, has, and will be on our planet. But it's only a mole of pennies. So start saving for my birthday present, a mole of pennies. And what I wanted to show you is a mole is a huge number. I'm off the screen huge. It's big. Now, by definition, one way of defining a mole that you should know, a mole is 6.02 times 10 to the 23rd things. Now, whenever you have two things equal to each other in a definition, A equals B, you can write two ratios. And those ratios are A over B and not equal and B over A. So if we have Avogadro's number, 1 mole of a compound, and this 1 is an exact number, 1 mole of a compound equals 6.02 times 10 to the 23rd things, which means, whoops, pressed the wrong button. You can write this ratio, 6.02, this side, divided by this side, 6.02 times 10 to the 23rd things for 1 mole, or 1 mole per, and per means A per B means A over B. B for A means B over A. And when you have A equal B, you can have these two ratios. And the same thing is true here. Now, good news, and I'll talk about it probably tomorrow. This will be an important information, test number 2. In the past, students had to memorize this, and the next couple of things I had to cover, but that will be given to you in important information. Now, as you know, I hope you know, this class is about chemistry. And chemistry, do we talk about things? What do we talk about? Atoms and molecules. And by definition, this is one of the most important things in chemistry to Dr. White. 1 mole of a compound or element equals Avogadro's number, 6.02 times 10 to the 23rd atoms. 1 mole of a compound equals 6.02 times 10 to the 23rd molecules. And when we have that, there are two ratios that you can have. 6.02, remember when you have A equal B, there are two ratios, A over B and B over A. So if I call this A and this B, we have Avogadro's number, 6.02 times 10 to the 23rd atoms or molecules per 1 mole of either element or compound. We also have 1 mole for 6.02, and this would be of either elements, which would be for atoms, or of compounds like water, which would be molecules. And you have these two ratios. And please be patient. If we were in a classroom, you'd be watching me write this on the whiteboard. All right. You should know how to use, this will be given to you important information, but still, this and another concept I'll be teaching you in a little while, not today, tomorrow, are extremely important. 1 mole of an element equals Avogadro's number. You should know 6.02 times 10 to the 23rd is Avogadro's number. 1 mole of an element equals Avogadro's number of atoms of that element. 1 mole of a compound, like water, equals 6.02 times 10 to the 23rd molecules of that compound. If I have a mole of water, I have 6.02 times 10 to the 23rd molecules of water. If I have a mole of sodium chloride, I have 6.02 times 10 to the 23rd molecules of sodium chloride. If I have a mole of sodium, that's the element, I have 6.02 times 10 to the 23rd atoms of sodium. If I have a mole of calcium, it's an element, I have Avogadro's number, 6.02 times 10 to the 23rd atoms of that element. And on your screen, you'll see test number 2, important information. And in the past, students had to memorize this. As I mentioned, I've cut way down on memorization, but this is stuff you have to learn. And that makes your life a little easier. Shh, don't tell anybody I'm being nice. Shh. But as I said the first day of class, I write my test to test your knowledge of of chemistry. Almost got that backwards. I test your knowledge of chemistry. I'm not testing your knowledge of chemistry and your memory. And that's why I give you this and this. Now, I'm going to be teaching you something important. That's a way of how to solve. Take a deep breath. You don't have to close your eyes, but it looks nice. Let it out. Take a deep breath. Let it out. Are you relaxed? We're going to do some word problems. Relax. That you'll have to do some minor algebra. Relax. And I'll show you a way how to do that that helps students. It's helped me for many decades. Or I shouldn't have said it, but it's true. Let's look at a problem. All right. Question is 5 points. I could have made it 6 too. How many moles of water, H2O, are now you can see the decimal, 7.36 moles of water. Well, what do? I want the 5 points. I hope you do too. Also, you learn something important. What are you being asked to find? How many molecules of water? So I like to put a question mark. Then the units of what we're trying to find. And it's important to put the chemical formula. What are we given? How many moles are 7.6 moles of water? 7.36 moles of water. So once we have this, we never have to go back and look at the word problem. So how do we proceed? It's time to use your good buddy, your good friend, unit analysis. I love this. By the way, these are no longer available. I've got 4 of them. Luckily, I bought them long ago. Company in Germany, actually, when they made it, it's called West Germany, makes these, and they're out of business. But the ones they do make aren't as good as that, which is why they'll never leave my house. So how do we use your good friend, your good buddy, unit analysis? Well, to solve this, how many moles? The only number I have to work with is that. Now, if there are a magic ratio that I could do to get to my answer, what units do I want my answer to be in? Molecules of water. And now it's time to use your good buddy, your good friend, unit analysis. Well, by the way, I'm going to be going through trying for the Guinness Book of World Record, saying your good buddy, your good friend, unit analysis the most times during a semester. Keep count. All right, how do you use unit analysis? Whatever units you're trying to get to goes on top of the ratio. Whatever your units you're trying to get to in your answer goes on top of the ratio. Whatever units you want to get rid of, I don't want moles of water in my answer, goes underneath of that ratio. So on top, molecules of water, underneath, moles of water. Now, where do I get these numbers? Well, what are we looking for? A relationship between moles of a compound and molecules of a compound. And important information, test number 2, almost got that wrong. 1 mole of a compound equals Avogadro's number of that compound. Again, when you have one thing H equal another, there are 2 ratios you can always have. A equals B, A over B, B over A. 1 mole of a compound, A, I'll put that at the bottom, equals Avogadro's number of molecules of that compound. And that ratio, that's how I got this number. Now, before we continue and pick up our calculator, I'm going to use unit analysis again. Now, anything divided by itself equals the number 1 and is gone. Anything divided by itself equals the number 1. Therefore, if we look here, we have moles of water divided by moles of water. And because anything divided by itself equals number 1, this cancels out and becomes the number 1. And 1 times 7.36 is just that. And when that cancels out, the only units we have left are molecules of water. Is that what we want? And the answer is yes. So now I'll pick up my calculator, clear it, 7.36 times Avogadro's number, 6.02, blue second key double E, 23, and I multiplied equal, and my calculator gives me this number. Now, on test 2, like test number 1, it will say, please use proper significant figures for all calculated answers. And this is a multiplication division. Multiplication division, you get the same number of significant figures in your answer as the number you're multiplying, dividing that has the fewest significant figures. This has 3 significant figures. All non-zero numbers are significant. Avogadro's number, 6.02, is 3 significant figures. This 1 is an exact number and has no role in the calculation. So my answer should have the same number of significant figures as the number that has the fewest significant figures in my calculation. 3, 3. I have to round this off to 3 significant figures. So I keep the 4, keep the 4, keep the 3. This is the number I round off. I use those double squiggly lines to show to round off. Is that 4 or less, or 5 or higher? And 4 or less, so I drop this, this, this. My answer, 4.43 times 10 to the 24th molecules of water. And that's how you use your good buddy, your good friend, unit analysis. Now, in high school, senior year, when I took advanced placement chemistry, the high school I went to, Niles West, was known for having the most outstanding science fair projects in the state of Illinois, and also the most Westinghouse winners in science. And we were trained in AP chemistry to do problems quick. For the Westinghouse exam, for that competition. And Mr. Salners, I still remember his name, great man, who was the department chairman of science at Niles West and the chemistry teacher in AP chemistry, taught us unit analysis, and we would take practice tests, not for our grade, but for the Westinghouse test, where normally you'd have an hour, we'd only have 20 minutes. That was to get us good at unit analysis. Now, important thing about unit analysis, it tells you if you made a mistake. What if we started with this and I messed up this ratio, and I put moles on top. By the way, this is wrong, but I want to show you. Moles of water, and here I put molecules of water. Again, this is wrong, but students do this. Now, how can I tell that's wrong? Well, if we do the unit analysis, we have moles, water, times from here, moles water, divided by molecules water. This is the units of our answer if we do it wrong. And this is not what we want. It's wrong. But when you do it correctly, up here, you have moles of water times molecules of water divided by moles of water. And remember, anything divided by itself equals number one, meaning it's crossed off. Notice here I have moles of water crosses off. What am I left with? Molecules of water, which is what I want. And that's how your good buddy, your good friend, unit analysis keeps you on the right track to getting the problem right. And you don't have to memorize anything. You just have to remember, if you have a ratio to convert this units to this units, whatever I'm trying to get to goes on top of the ratio. Whatever I'm trying to get rid of, the units go on the bottom. And you get these numbers from relationships up here. Oh no. If I look at the clock, we're out of time. Time flies when you're having fun with moles and Avogadro's number. Now, remember, tomorrow, the lab is due we did last week. Don't forget to take a selfie. And if you need help, always come to my office hours. And with that, tomorrow we'll go back to moles, but we'll do the lab first. With that, oh, I forgot. Tomorrow we'll do the lab first, then we'll do the practice problems for chapter 4. And I'll be cutting the answers from test number 1 out of the video that I'll publicly post, this one. But by tomorrow evening sometime, I'll post a private video of the answers for test number 1. Then I'll also send out an individual email to each of you with the URL. If you're not here today, you can see it. With that, remember, Yiddish, gehen gesund means go and help. Goodbye, gehen gesund. See you tomorrow.